Hello and welcome. Today we're going to talk about expected value. Um, so expected value can be called many things, but the most common ones is that you refer to it as the expected value or the mean, and then you refer to it as the expected value of a random variable x. And sometimes you might also say just the expectation of x. The one that we're going to use most frequently, however, is the expected value term. You denote it as e of x, which we have here then, or you can also use the Greek letter mu or mu of x, so this means that you refer to the expected value of x. Uh, Usually in finance we talk about expected returns, not always, but it's very common at least. And then a normal notation is to write e of r instead of using x then, because r would stand for return. Okay, so what is expected return? Well, imagine a game that works like this. You draw one card from an ordinary deck of cards, and in case you draw a 7, then I will give you 2000 Swedish kronor. And if you draw anything that's not a 7, then you have to give me 100 Swedish kronor. Okay, so we have two possible events. One is that a 7 is drawn, and if that happens, then the outcome for you is a positive inflow of 2000 Swedish kronor. And the other event is that anything else than a 7 is drawn, and in that case you lose 100 kronor instead. So what is the probability that you draw a 7? Well, a normal deck of cards has 52 cards. Out of those, 4 are a 7, so the probability to draw a 7 is 4 divided by 52. And on the contrary, we have 48 other cards, so the probability to draw any other card is 48 divided by 52. You might note here that the probability is summed to 1, so 4 divided by 52 plus 48 divided by 52 was 1. So if you draw a card, then it's a 100% chance that it's either a 7 or something else. Okay, so let's assume that we played the game 52,000 times. Okay, so how many times would you expect to draw a 7 then? Well, again, a deck of cards has 52 cards, so on average each card should be drawn 1000 times. And since there are 4 sevens in the deck, that would mean that you would assume that you would draw it, well, 4,000 times you would draw a 7, and 48,000 times then you would draw something else. So the total expected win that you would assume is that you would gain 2,000 kronor in 4,000 cases, which is a total gain of 8 million kronor. And the expected loss then would be the 48,000 times you do not draw a 7, where you lose 100. So you would lose, on average, 4.8 million kronor if you play it this many times. And the total expected net profit then would be 3.2 million kronor. Okay, but how much is that per game? Well, the average net profit per game then you can find by taking the expected profit and divide it by the number of games that we used, in this case 52,000. And we find that, well, on average you should win 61.54 kronor per game. Okay, so let's go to some mathematical formulation and definition of an expected value. So the expected value is defined as the sum, let's say this is the sum sign, of the probability that an event happens times the outcome if that event happens, and then you sum this for all possible outcomes. If you write it more easily to read, maybe, then you would have it on this form. So the x1 is the outcome that would happen in case event 1 happens. So in the card game, maybe our event 1 would be that you draw a 7, then the outcome was 2,000 kronor. So if you draw a 7, then you get x1. P1 denotes then the probability that event 1 happen. So in the case of drawing a 7, the probability that event 1 would happen was 4 divided by 52. And the number n here, it denotes the number of possible events. So in case you only have 2 events, like in our case, we would only have this P1 and P2, and the rest would simply not exist because n would here be 2 and the sum would stop after that. So if we do it with our example then, we are supposed to follow this formula now. So we're going to start by taking the probability that a 7 is drawn. So that's our event 1. We find this probability here, and we start by just writing it down. Then we're supposed to multiply it by the outcome in case event 1 happens, so x1. The outcome is found in the table, it's 2000 kroner, and we simply multiply that. After that, we are supposed to add the probability that event 2 happens, which is found here, 48 divided by 52, and we multiply that by the outcome in case event 2 happens. So whenever any other card is drawn, you lose 100 kroner, so we multiply by minus 100. And we find that the expected value, given this formula, is 61.54, which, if you remember, was exactly the same amount that we were expecting to win on average if we played the game many times. And again, this Pn times Xn, it's not going to appear in this case, because we only have 2 events and we only want to take into account all events. So the N stands for consider all possible events. And since we only have 2, we already done that. Okay, so the expected value that we got, 61.54, it corresponds to the average outcome if the game is played in many times. But the thing is, if we only play the game once, the expected value we cannot get 61.54 at any game, because either you win 2000 or you lose 100. So there is no possibility to gain 61.54, even if that would be the outcome if you play on average, if you play it many times. So that is why in the next move are going to talk about something called variance. I hope this helped you. Thank you very much.